Hello, welcome back. This is Calculus by Dr. Oz. We are given rectangular equations and we're going to convert them to polar equations. And rectangular coordinate system, which is the XY coordinate system that we're used to from calculus, is now converted to polar coordinate system where you have no x and y but r and theta. And in each case, we're going to convert everything to the polar form. And at this moment, I want to remind you about the coordinate conversion because once you have the xy coordinate system, you can convert it to the polar coordinate system. And there's a relationship in between. So let's say from polar to rectangle, the relationship is x equals r cosine theta and y equals r sine theta. So essentially, if you know the polar form, that means you have the r and theta entry of the point. So then you can find the xy entry of the point through the first set of equations in the first column. And in the second column, this is telling us how you go from rectangular to polar. Essentially, if you know x and y coordinates of a point, so you can use tangent theta equals the ratio of y and x. And it tells you the tangent value, so that means you have to consider arctan of y over x to be able to come up with the theta. And the relationship between rx and y is found by r squared equals x squared plus y squared equation. So if you know x and y, you can go ahead and then find r for that. And then these two equations tell us what the r and theta entry of the point. I'll give you more details of the conversion because we have changed the coordinate system from the rectangular to polar. And in each case, please have your calculators ready. And as well, we're going to try to make a table of sample values. So also, please get ready for that. All right, let's start.
All right, let's take care of part A. So we have x squared minus y squared equals 9, which is written in the rectangular coordinates x and y. And we want to migrate to polar form from rectangular equation form. So let me just remind you about this table. So this table is telling us how we can convert in between different coordinates, in fact, polar and rectangular coordinates. Okay, so here, if you are given everything in the polar form, that means you know r and theta entries of the points. So by plugging those back in here, you can go back to the xy formulation. And if you're given the rectangular formulation, that means you know the x and y. So then you can just plug those back in here to get back to r and theta formulation. For the time being, I'm going to use these two formulas to convert x squared minus y squared equals 9 to its polar form. And as you can recall from the previous section, this defines a hyperbola. Okay, so let's see what we can do for it. So x equals, as I said, r cosine theta and y equals r sine theta. Okay, so what is x squared minus y squared based on this transformation? So x squared minus y squared equals r squared cosine squared theta minus r squared sine squared theta. Okay. By the way, since we're doing the polar coordinates here, please have your unit circle with you because we may rely on to unit circle values as well as the trig formula card. Please keep those with you because we may heavily rely on to these formulas. Okay, so here I'm going to factor r squared out. So we have cosine squared theta minus sine squared theta. Okay. And in fact, this is the double angle formula for cosine. So this is equal to cosine to theta, so that this is rewritten as like r squared cosine 2 theta. Okay. All right. So that means r squared cosine 2 theta equals 9 is the polar form of the same equation, same rectangular equation, and we can just sort of like solve this for r and write it as like r equals 9 over cosine 2 theta and radical. Okay, And this defines a hyperbola, as I said, and you can go ahead and then polar graph this function here, r squared cosine theta equals 9. And let me just show you what I got, but please have your TI-84 with you. You can also plot x squared minus y squared equals 9, but here the whole idea is to use the polar coordinate system more than the xy coordinate system, because that's where we are heading towards. So eventually we're going to be given only the polar equation, and we will try to graph that accordingly. All right, here's what we have. So we have a hyperbola. As you see that I have 3 and -3 here, so this is what A is. You can go ahead and check the foci and other related stuff, asymptotes maybe, because we have asymptotes here, right? Well, center is located right here. So you can check all of these properties, but the whole idea here is that try to use your calculator and put it in the polar form and directly feed the polar equation that we got here, which is r squared cosine 2 theta equals 9, or you can just enter r equals radical 9 over cosine 2 theta, and please get the 2 branches of hyperbola at the end. All right, that takes care of part A. I'll see you in the next video to take care of part B. Bye.